Hello everyone, welcome to a series on statistical significance testing. So in this video we are going to talk about chi-square test. So without further ado, let's dive in. So chi-square test is here mainly for analyzing the association and correlation between two categorical features or variables. So what is categorical variable and what is association? Let's talk about those two things with an example. For example, if you are trying to see if marriage status has significant correlation with educational qualification, that is one example where you can actually use chi-square test. So why are these two variables categorical? Because there are only a fixed number of possible values for marriage status. For example, you can be single, you can be married, or you can be divorced. Also, there are just a fixed number of labels possible for educational qualification. For example, primary pass, high school pass, then there can be a college passed, master's, PhD, maybe all of that, yeah. And I'm not really seeing anything else here. So if you want to look at this, you need to collect some data. So suppose we collect some data and the data consists of 150 people in total, and we note down their marriage status and their educational qualification, and we make this table. So you can see that there are three qualifications educationally, and there are three status of marriage, and we can see these numbers. For example, we can see that there are 30 people who are married and who have a master's degree, and there are 10 people who have a master's degree and who are also divorced. So these are row total and these are column totals. That means there are 55 single people, 25 divorced people, and 50 high school students. And in total, we have 150 samples in total. So this entire table is called observed data O, because this is what we observe in the real life. Now what we are going to do is we are going to calculate this expected table as well. So suppose we don't know these values in this table. We only know the column total and the row total and the total number of collected data. If we know those numbers, then what is the expected number of people who are single and who have a high school degree? Also, what is the expected number of people who are divorced and who have a master's degree? So there are 9 such possible cases. How do we fill that up? Let's say example for high school and single. So we are going to get 50 and 55 right here, multiply them together and divided them by 150. Very typical thing. I think we all know how this is being done, and this will give us the expected value. Same thing will go here. So if we want to get it for divorced and for masters, we just multiply 50, which is in the master's row, by 25, which is in the divorced row. We multiply them up and we divide by 150. So if we continue doing that for every possible case, then we are going to get this table. Now, this table is going to be our expected data E. Now, understand that here, I mean, by chance, the rows became equal and by chance, the columns became equal, but they don't have to be equal. They can be unequal as well. So that's no big deal. Next thing we want to do is we want to get the chi-square table. So how do we get that? We have the observed table O. We have the expected table E. So how do we get the chi-square table chi-square? It's actually quite simple. Chi-square value is nothing but the relative difference between observed and expected values, right? So how do we get that? Suppose we want to get it for high school and for single case. In that case, we are going to get this value, which is the observed, this value, which is the expected, minus and whole square, because we want to avoid the negative signs. And then we divide by the expected value for the relative case, basically. So we can do the same thing for every one of these cases, every 9 cell. Let me show you one more time. So if we want to do this for masters and divorced, we can get 10 and 8.33, negate them, whole square, and divide by expected value. So if we keep on doing this, we get this whole chi-square table. And in order to get the chi-square value, we have to sum all of these things together, which is going to give us 12.79. Okay, so if you have a larger chi-square value, what does that mean? That means you have a higher deviation in your observed data compared to what you expect. That means your values are more extreme. And when your values are more extreme, you have a lower p-value. Now, p-value also depends on the number of independent observations, which is also called degrees of freedom. Now, understand that total number of samples you collected is not equal to the degrees of freedom or the independent observation. Okay, so we are gonna show in a second how to get that. So this is how you get that. It is going to be row number -1. So in our case, there are 3 rows -1. into column number -1. There are 3 columns, right? -1. So it's going to be 4. Now, why do we subtract 1? Because if you know two values of a certain row and the sum of the row, then you can just derive the third value by subtracting the rest of the two values from the row sum. Same thing for the column. If you know two values of the column and you know the sum of the column values, you can easily get the third value by subtracting the rest of the two values from the sum of the column value. That is why you have to subtract 1 here, and that actually talks about the independent thing, which is the degrees of freedom basically. So this is a p-value table for the chi-square test. You can see that there are different p-values having different chi-square values, and if you have a higher chi-square value, you have a lower p-value, which I just mentioned right here. So in our case, the value is 12.79. So you can see that 12.79 is higher than 11.143. And at 11.143, we already have a p-value of 0.025. So this is going to be less than 0.025 in our case. That means, obviously, it's statistically significant under the significance level of 0.05. So if you imagine that your significance level is 0.05, then you can reject the null hypothesis. That means educational qualification and marriage status are significantly correlated with each other. So that's all about chi-square test. I hope that this video made the concept simpler for you guys. If you like the video, feel free to subscribe and share, and you can donate to our channel, so the link in the description. Thank you very much.